Question 1 has to do with absolute and relative change. So we'll go ahead and look at this example here. We know that absolute change is given by new minus old. And so for the question that we have, the absolute change will be 52.23 minus 49.48. And so the absolute change here will be $2.75. The relative change is new minus old over old, where the old value is the reference, same as the absolute change here. And we can also determine the relative change by doing absolute change over the old value. So the relative change here will be 275 divided by 49.48. And so the relative change will be 5.6%. Question 2. We know that new equals old, 1 plus or minus percent. So the percent can be an increase or a decrease. In this case, it tells us that the new book costs 27% more, and so there is a percent increase. And we can also use equal proportions to solve this. So using the formula, we have x to be equal to 91 plus 0.27 since we have a percent increase. And this gives us 1.27 times 90, which is 114.30. Using equal proportions, we have x over 90 to be 127 over 100, and that gives us the same value. Similar to question 2, we'll do the same here. New over old equals the percent over 100, or again, we can use the formula new equals old, 1 plus or minus the percent. So again, this can be a percent increase or decrease. Since we have a percent decrease, this becomes, and then we can solve for x by dividing both sides by 1 minus 0.108, or we can just solve for that, divide by both sides. This cancels out, and so what we are left with is x becomes that. To set up the linear model, which is given by y equals mx plus b, we need to determine what the slope is, which is m, and then our y-intercept, which is b. From the information we have, you spent 10,000, so that's an amount spent, so that's a negative. And then if you're selling each alpaca for $200, that represents the slope because the slope represents the absolute change in y divided by the absolute change in x. And so our model becomes 200x minus 10,000. To determine how much profit or loss, the amount in terms of profit or loss is given by y, and then the number of alpacas is given by x. And so in this case, we're solving for y. So if y is 200x minus 10,000, then we can put in place of x 24 and then solve for y. To break even, that is the point after which you start making profit. So when y is equal to 0, so again, using our model, y equals 200x minus 10,000. We can add 10,000 to both sides, so this goes away. So ultimately, we have 200x to be equal to 10,000. Divide both sides by 200. X will be equal to 50 alpacas. We're given a trend line equation here. Since the graph is given in the literal year, what we need to plug in is 2004. If y is given us in place of x, we'll put 2004 and then solve for y. So the actual value for 2004 is what we have here. And so based on the calculation that we did, we can say that the model is higher than the actual. And we can see that the actual is under 3,000. To interpret the meaning of the slope, since we know the slope is given by change in y over change in x, we're looking at a ratio of the enrollment divided by the years. So we can say that enrollment increases about 178 students on average every 2 years. Now, since the year 2020 is outside the scope of the model, we said that the scope of the model represents the range of the horizontal values. And so if the scope of this model goes all the way to 2010, then 2020 will be beyond the scope of the model. And so no, because 2020 goes beyond the scope of the model. For exponential models, growth or decay, we have the amount to be equal to the initial value. In this case, since we are told that the number of followers double every month, we're looking at a growth factor. So we have an exponential growth to the power t. The number of followers will be equal to 100. The growth factor will be 2 to the power t. So this represents the model. So if we want to know the number of followers after 4 months, then we have the amount to be equal to 100, 2 to the power 4, which gives us 1600 followers. To reach 1 million followers using guess and check, since our model is given by 100, 2 to the power t, all we have to do is plug in some values for t that will get us to 1 million followers. That is when we'll have about 1 million followers. We looked at how to calculate finance charge, new balance, and then minimum payment. We said the finance charge is given by the annual percentage rate divided by 12 times the balance. The new balance becomes the balance plus the finance charge, and you only pay finance charge when the balance is not paid in full. And the minimum payment is a percentage of the new balance. So if you start out with $300, the finance charge here will be 0.15 over 12 times 300. That gives you $3.75. And so our new balance becomes 300 plus 375, which is 303.75. And then the minimum payment is a percent. So the minimum payment here is 2% times the new balance, which is $6.08. And then the carryover balance will be the new balance minus the minimum payment. So that will be minus 6.08. So we have 297.67. And then we repeat the same calculation. To determine when interest is compounded annually, we use the balance equals the principal 1 plus the rate to the power t. And so the balance here will be the amount invested, which is the $1,000, 1 plus 0.04 to the power 2. If the interest is compounded monthly or periodically, then the general equation we use is 1 plus r divided by n, when n represents the number of times compounded. So if it's compounded monthly, then n will be equal to 12. And so the balance becomes, when you're dealing with 401k, the Excel function to use is the FV function. The FV function has the annual percentage rate over 12, so 0.015 over 12, comma, the number of payments, so 12 times 20 years, and then minus the amount that you invest, which is 100. We talked about the rule of 70 for doubling time, which is given by 70 over P. So for anything that has a constant growth rate, we can determine how long it will take for it to double. So 70 over 3 gives us 23.33 years. To find out the mortgage payment, we use the PMT function. And so we have our monthly interest rate, 12 times 30 to represent the number of payments, and then minus 125,000, which is the loan amount borrowed. In this case, we're assuming that you borrowed the full amount from the bank without any down payment. So if Excel returns this value, then how much would be paid on the mortgage in total? So if you end up paying this amount every month for 30 years, that will be equal to determine how much interest is paid over the lifetime of the loan, we take how much you end up paying, and then we subtract how much you borrowed from the bank. And that represents the interest that will be paid on the loan. To determine the total expense ratio, we take 36% of monthly gross income minus monthly housing expenses, and then minus any monthly loan payment. In this case, since we don't have the monthly gross income information and all we have is the monthly loan payments and then how much goes into housing expenses, we have 750 minus 150, and that gives us $600. To determine how large of a mortgage Johnny can afford, we use the PV function. And so we take the rate divided by 12, 12 times 30, which is the duration, and then minus 600. When you enter this into Excel, it will tell you how much of a mortgage you can afford.